way down at the, oops, at the, can they still hear me? Okay, at the bottom of the page on the right. But I came in and I circled in a yellow outliner all the things we had looked at and attempted to look at that night. We had the star party. So anybody that wants, you still have them, right? Okay, so anybody who wants, I've already given Sandy hers and Laura hers. And so the rest are here for you if you want them. Ba-dum. All right, so the summer triangle. Now, okay, can we also put up, remember you had Sagittarius and Scorpio up last time? Is that still there or do we have to find it again?
I think I have to find it again.
Okay, so Melanie is going to find another image for us to look at, and that's the two main constellations that were in the southern sky.
What was it?
Scorpio and Sagittarius. So she's hunting for those, and then you can choose. Remember, we had a series that we could pick from. Just choose the best, clearest image. All righty. Yes, Bob.
Just, oh, there's a little break here. I have to leave about 1:15, so I'll just disappear and I'll still be here, okay?
Okay.
Okay, just wanted to let you know.
All righty. What, are you still here then to answer a question?
Until 1:15.
Okay, well,
No,
wait a second. Isn't it already 10 after 1?
no, I'm sorry, 1:45, sorry.
Okay, all right, okay.
Do you like
So,
this one?
We've
yeah,
got
those are good. Those are good.
35 minutes.
All righty. So Bob,
So,
when we looked at Scorpio over to the west and low in the southern sky, here we go. Can you guys see the screen yet? Not yet. Okay, in a minute she'll have the screen up. There was the main alpha star that I pointed out that you tried to find and we couldn't with the bird scope. Once again, just showing us how difficult it is to find a star with a telescope. Anyway, that's another story. So here we are. Is it on screen now for them?
Yep, it should be.
Okay. Can you
It
all
was.
see on your
Oh,
screen?
did I think I,
it's gone.
It came and went, huh?
it came and went.
All righty, we'll find
Okay.
it again.
There you go.
Okay, Bob, tell
There we
us what,
go.
just in a minute, something about antares. And then we saw that with our naked eye, red supergiant, I think. And then M4, a globular cluster right near it, which we had a hard time seeing because once again, the sky was
Yeah.
hazy and we only had about an hour of relatively dark skies before the moon popped up at around 10 o'clock. So most of us, I don't think, saw M4, but do you want to tell us anything about those that you might know?
Was I supposed to know? I
No.
No, I was spending so much time trying to find things with the scope. I missed a lot of the discussion.
Okay. And Jordan wasn't there.
Was
Ma-
Bob able to find, what was I supposed to find? Deneb?
No, you were supposed, Alberio, we didn't even try for
Okay.
Alberio because,
Alberio.
no, we didn't even find it. Well, I'll tell you what then, Bob, tell us what happened when we first got there and Jerry spotted Venus in the west. Do you remember that or were you too busy setting up your bird
Yeah,
scope?
no, I was able to get the scope on Venus and we had a very good view of it, actually.
Mhm.
Still just a little spot, but with the spotting scope.
All right.
That's
now-
what I remember.
For Jordan out on the West Coast, we didn't have a telescope as such. Bob brought along his bird scope on a tripod, which was really nice because it didn't wiggle. Any of you that have tried to hold binoculars and keep them from wiggling, the tiniest wiggle, you lose a lot. So, Bob, I think I asked you, did Venus look like a full moon, a part of a moon, or a crescent?
Oh, to my eye, it looked like a circle. I didn't really see a crescent.
No,
type shape.
okay. Sometime this winter, we'll be going through, like next time, I decided we would look at Jupiter and the moons because of our experience. Sometime in the winter, we'll take a look at Venus. And we will have then diagrams on the screen, which will point out the fact that because of where Venus is compared to us and the sun, sometimes it's a crescent and sometimes it looks like a full moon and sometimes in between. And oddly enough, when it's a crescent is when it's brightest from our vantage point. And we'll go into why that is when we talk about Venus. So it was fairly easy for you to find because it was so big and bright, right? And it was also, there were some scattered trees to the west, so you could kind of find it somewhere there in a frame. Then we
That's right.
found Jupiter. And I want to put that off for a few minutes, but once again, that was where? That was in the eastern sky. And because it was so big and so bright, you were able to put your scope on that too.
That's right.
All righty. Can we make the image bigger, Melanie? So she can't make it bigger. All righty, but you have the marker. Okay, if you go down about just above that M7.
Mhm.
Okay, we talked about how the Earth goes around its orbit through the seasons. And in the summertime, when we can see Sagittarius there low to the horizon, to the south, at around 9, 10, 11, 12 at night, if you look just to the right of that, who remembers, Mary Lou, do you remember where we're looking when we look to the right of that, where the little arrow is?
You were talking to me?
Yep.
Yeah.
Okay. Are
Okay.
you talking about M22, the galaxy?
No, I'm talking about somewhere in our galaxy. In what direction are we looking when we look towards the right of Sagittarius? Do you remember? By the way, for the people that weren't there, who aren't here either,
You're
but will be
looking south. You're looking south.
yes, but you're looking into the center of the Milky Way galaxy, which is why from the upper left, around 11 o'clock on this rectangle, down to the lower right, we saw the Milky Way. And the Milky Way really is our view towards the center of our Milky Way galaxy. And that's why we see so many stars in that strip of the sky. Whereas in winter, picture it in your head, put your one index finger on the table, that's the sun. And then we're making a more or less circular orbit around the sun with our other finger in hand. And at one time of the year, nighttime is away from me, and that's looking out of the Milky Way galaxy. Whereas when I come halfway around towards me, nighttime is towards the center of the Milky Way galaxy. And I'm not sure if we'll have time at the end of this hour. And mostly, I think Jupiter is going to take up the whole next time. So maybe in a month, we'll talk about the Milky Way galaxy and our place in it. So, okay. All righty. We want to point out M6 and then M7 right there. Bob, where I forget.
Yeah.
Well, once again, when you have 8 people and one scope and a bunch of binoculars and everybody talking and getting excited, it's hard to keep track of what's going on. So I don't remember.
Yeah.
Were you able to pick up, or Mary Lou with your binoculars? I tried to help you, I remember. Could we find M6 and M7 to see or not?
No, I couldn't see those.
Okay,
I
Bob?
found M22.
No.
That's the only one.
Okay,
No.
okay, Bob, what?
No, I think it was over to the right, the bright yellow thing. That's a nebula? Arterius? I can't read it.
Okay, we'll get to the nebula in a minute. M6 and M7 were open clusters.
Yeah.
Young stars, by that I mean, 10 million, 100 million years old. That's young
Yeah.
in terms of star
Yeah,
dates.
yeah.
And the M6 is called the butterfly because with a telescope, it's sort of butterfly shaped, the 2 wings. And I'm going to forget now which one's brighter. I think M6, but you can double check. They're quite close. You can see them with your naked eye because they're both in the magnitude like 5.5, between 5 and 6, which is clear skies, good eyes. You can see naked eye. And the M7 is the Ptolemy, that old amazing person that lived down in Egypt under the Greeks back in what? The 2nd century. And he put a lot of things together, including travel logs and a map of the sky, et cetera, et cetera. Ptolemy is a very important person, partly because, let's see. Augustine in the 400s, that church founding father, and Aristotle, 500, 600 years before, both decided, Ptolemy's right. The earth is in the middle of everything. Well, of course, we know he's wrong. But for 1,000 years, Ptolemy and his writings ruled the roost through the Christian church. So we'll talk about Ptolemy sometime in the winter when we have time to do some of these, mostly, all men who studied the skies over the more than centuries, thousands of years, some of them. Okay, so the difference between M4 and M6 and 7 is M4 was a globular cluster, ancient stars that were created early on in the beginning of our solar system, close to 14 billion years old. So they're old. Unlike the young stars in the open clusters that exist in the swirling arms of our spiral galaxy. And once again, later on, when we have time, we'll go over just the idea of these two kinds of clusters. And old Messier, who gave them most of them numbers back in the over 200 years ago. And we will find through our star parties, mostly the naked eye ones, if the night is clear enough. Our problem a week ago was it was hazy, and it hardly had gotten really dark in the west when the light from the moon began to cast its light in the east. So, okay. Does anybody, let's see, and then the last thing we looked at before we get to Jupiter was, now can you take your arrow and run it up this way at an angle? Okay, back and forth. I call that the upper edge of the Milky Way galaxy. If you were looking at the stars on a clear, bright night, that's where the upper edge would be. And I call it the escalator. And if any of you have more serious astronomy books that deals with constellations and or Messier objects, this whole area that surrounds Sagittarius is literally littered with M objects. Some of them are open clusters. Mary Lou, you spotted M22. You want to? Okay, why was that easy to spot, Mary Lou?
Well, it was large,
Okay, and where was it right next to?
and it was right next to the top of
Teapot, the
what I
teapot.
call the knob of the cover of the teapot.
Right, and that's why M4, if it had been a little darker and less hazy, would have been easy to spot also, because it's right next to Antares.
Oh, okay.
Whereas these two, M6 and M7, they're kind of hanging out there sort of by themselves, and they were harder to spot. So what we tried to do, did anybody see any of those emission nebula M8 and 20 or not? I think somebody did. They were like right up in here.
Yeah.
Oh, up.
Yep.
Okay, do I need glasses? All right, who saw them besides me?
I don't know.
What are they called?
And okay, once again, Messier saw them and labeled them, but they're nebula or nebulae or nebula, whatever the plural of that is. And they are simply huge clouds of gas and dust. And the reason they glow, there's two reasons. This is all review. There are young stars. They're like a nursery. That's where stars are born. in a cloud of gas and dust. And those young stars give off usually blue-white light. They're hot, intense. And that light can do one of two things. It can, this is up your alley, Bob, as a chemist, it can excite the hydrogen atoms that's in that gas cloud. Most of the gas is hydrogen, and knock off an electron, which zooms around for a bit, but electrons all by themselves don't like being lonely. They want to go back into partnership with the proton of that hydrogen. And as they fall back into place around their original, or well, another one just like it, they emit some energy. And that energy is partly in the form of light. And depending on the gas, hydrogen tends to give off a red wavelength of light. And so a lot of these clouds, M8, the lagoon, and M20, Trifid or Trifid, give off a reddish pinkish glow.
Mary Lou,
Yeah, okay.
when hydrogen gives off energy like that, because the electron gets back associated with the atom, it actually has 3 lines, 3 or 4 lines. The
Okay.
red one is predominant. In fact, I know where to go up. I'm going to run upstairs and get a book,
Okay.
and it has the spectrum of hydrogen in it. And I
Alrighty,
can
you
tell
wanna
you
do-
what the other ones are.
You want to do that?
I'll
Okay,
be right back.
Sure.
And still will be here.
okay. So the other reason we see, and that's called, what's that called? That's called an emission nebula, because it's emitting the light from the electron falling back into place with the proton, making hydrogen again. And most of it is reddish. The other is a reflection nebula. And then we see blue, just like we see our blue sky. And what is happening there, the light from the young stars is bouncing off all that dust. Remember, the nebula is dust as well as hydrogen gas, mostly hydrogen gas. And so just as, and maybe someday we'll talk about, why is our sky blue, mommy? But not right now, just accept it. For the same reason, it's bouncing off the dust, and we're seeing the blue wavelength. So until we get to Jupiter, I think, Mary Lou, you were there? Oh no, did Mary Lou disappear? Somebody disappeared. Everybody disappeared.
Everybody just.
And since I can't see Jordan, is he there?
Yeah, I'm here.
Oh, you're here. Okay. Well, did your mom talk to you this week to tell you all the excitement about Jupiter and what happened or not?
Not really.
Not really.
She
Okay.
didn't really say anything.
Pardon?
She didn't really say anything about it.
Okay. Well, here's what happened. Bob had gotten his bird scope all set up and stabilized. And after we had looked at Venus, Jupiter started coming up around my spruce trees. So we moved the scope out into the lawn further. And it wasn't too hard because once again, Venus was a beautiful silvery white color, but Jupiter is that more mellow yellow color, really sort of a light golden and quite bright. And he managed to focus on it. And I think it was your mom, Jordan. It was Laura who took one of the first looks through and said, because we had been talking that day about possibilities, and she got so excited and said, I see the moons. And I looked through and I said, really? She said, yes, there are 4 of them, 3 on one side and 1 on the other. And me being the dummy of the night said, I don't think you see all 4 all at once. And I looked through and it seemed like the one on the right by itself was higher than it should be. Because once again, when we look at Jupiter, what's so interesting about those 4 big moons, they circle Jupiter right above its equator. So, and Jupiter is, I believe, tilted slightly like we are, but think of a sphere, think of a long chopstick going through that sphere from north to south pole, then tip it slightly, then take an old-fashioned record or a CD player and put it somehow, stick it around, cut it in half, glue it around the equator. That's the plane of the equator. And those moons pretty much follow that. So from the Earth, they all line up in a line, especially when you can see the four of them together. Now, Melanie took a picture. When I got home, I realized, yeah, Mary Lou, you are a dummy, because there are 1 or 2 days in the month when all four are visible from the Earth. So we're going to try and find that now. Hi, Sandy. I see Sandy. Does that mean Sandy's here or somewhere? Is she able to talk?
She's muted right now.
Pardon?
She's muted.
Hi, Mary
Oh.
Lou.
Oh, hi, Sandy. Okay.
We wanna
What we're doing now, Sandy, is okay, can we see the whole month just briefly first? And then, well, what I did is I brought in my August, because we met at the end of August, the 24th. And every month, not only does it show the whole sky, it also shows Jupiter, which is the yellow ball down the middle. And then in 4 colors, the spiraling track of the 4 big moons around Jupiter. So that's quite amazing, but I've never paid any attention to it, because with my binoculars and wiggle, because I can't hold them steady, I could never see the 4 moons. So now, Melanie, let's just focus on the 24th, which was the night we were out there. Okay, now maybe Bob can explain in a minute why sometimes what you see in a book or a magazine is backwards from what you see with your eyes in the telescope. Where's the 24th?
Yeah.
Right here. Okay, there was the 24th,
Mhm.
but flip it over, because these 3 were over here on the left side in the scope, and that one was on the right side.
Yeah.
Bob, what has something to do with mirrors, right?
Well, yeah, a single lens inverts something.
Upside down, sideways, or both?
Well,
I never could figure it out.
it's both. But my memory is what I saw was what's shown here in the
Really?
picture. I thought I saw
No, I
the
think,
bigger one
well,
on the left and the 3, well, no,
no,
I
because
don't remember. So,
Yeah.
but definitely this is either what I saw or the mirror image of what I saw.
it was the mirror image, because the magazine says the top is south. And usually, you know, we in the Northern Hemisphere always put the North Pole at the top. So when you look at stars, everything's opposite of what you see or something.
Mhm.
Because I remember when I saw it, the reason I thought it wasn't the moons was the one, this one, which was off to the right, seemed to
Yeah.
me higher than these. Like at 2 o'clock,
Yes, it was higher.
at 8 o'clock. But that would be true since Jupiter, I forget what the angle is of its axis, is, here we go, is tipped slightly, you see. So instead of being straight like that on a parallel to the tabletop, it would be slightly slanted, but they all line up along the same line. So
Yeah.
we will go over these in the next month. Everyone's going to have an assignment, but it was so exciting. Mary Lou, you got to see them too, didn't you? Or
No,
not?
I didn't want to walk all, I didn't know you could see moons. And when they said, well, here's Jupiter, and I didn't want to walk all the way across the lawn.
Ah, right.
I
Okay.
knew there was moons, I would have.
Ah!
So
Okay.
I didn't bother to go.
All right. You know, as time goes by, everything is going to get better. These first star parties, remember the moon came up practically right away at the first one. Well, you all had a blast out there in the field. I didn't go out across Sandy's field to the pond when the moon came up either, because of the uneven ground to walk on in the dark.
May I say something? But on our way home,
Yeah.
after we turned from McAndrews onto Jericho Hill towards Alfred, there was the moon on the full moon on the horizon, and it was orange. It was
Yes.
beautiful.
I was driving home that night and I don't think I've ever seen it so orange. It was incredibly orange
Yep.
that
It
night.
was
It
beautiful.
was two, Mary Lou, it was 2 nights past full. Sunday night was full moon, and this
Yeah.
was,
But it still looked round.
well,
mean,
yes,
look-
sometimes, especially near
Yeah.
the, let me think, the equinoxes,
Mhm.
it
Yeah.
take, and maybe once again, we need to have just a moon program sometime in the
Yeah.
winter when we have time, because during the March and September, because of the angle of the ecliptic, the middle of the highway, it takes longer for the moon to set or to rise in the morning. Therefore, it seems, remember that optical illusion? It seems bigger than it really is.
Yeah. Yeah.
Now, Jordan, you're out on the West Coast, where evidently this morning they had to evacuate South Tahoe City of 25,000 people, down only 2-lane roads, winding roads down through the mountains. What's causing these incredibly golden orange moon rises and sets?
And the huge wildfires,
Yep. So what's that doing to the atmosphere?
putting a bunch of smoke up in the atmosphere.
Yep, it's going all the way up into the stratosphere. And at our latitudes, which way do the majority of the winds blow? From where to where?
West.
Don't they go east?
They go to the east. Yep. So, if you lived here, if you remember, the winds usually come across the field from the west, maybe the northwest a little bit in the winter, southwest in the summer, but generally west to east. Okay. So,
Mary Lou,
yeah.
I have those.
Okay.
Those
Why don't you explain them,
colors.
Bob?
This is the, in the spectrum of hydrogen, that is the emission spectrum. The red, which dominates, is at 656 nanometers, which is the thing used these days for wavelength measurement. And then there's a green at 486 nanometers. Are you there, Mary Lou?
Yep, I'm here. I heard you at 6. It gives you the
Four-
green.
486 nanometers. And then there's a blue at 434. And then almost out of the visible spectrum, there is a narrow line at 410 nanometers, a little bit shorter, and you wouldn't be able to see it. And that's really in the indigo. There's that memory aid for knowing the spectrum, Roy G. Biv,
Yep.
red, orange, yellow, Roy G, green, indigo,
Blue,
green,
indigo, violet.
blue, indigo, violet. And the most shortest wavelength one at 410 nanometers, that's really in the violet. The 486 one is, well, it's nominally in the green, but it's clearly has a blue cast to it as well. So those are the 4 lines with the red one dominating. And what's happening is the electron in different excited energy states, when it gets down to the ground state, it emits different amounts of energy, which is why you see the 4 lines in that emission spectrum. Helium has 1, 2, 3, 4, 5, 6. Now, if you want to get complicated, there's uranium here, and it's got about
Bob.
about 150
Bob.
lines. Yes.
I'm going to take my hook and pull you off stage because
Okay.
once again, sometime in the winter, we'll be coming up like on our annual anniversary. And then I'm thinking, if you all are willing, I want to go a little deeper into the science of how, up till now, we talked about the color of the stars and how that indicated how hot they were. Well, how do we know that? How do we know that red is hotter than white? And how do we know that Antares, is whatever it is, so much hydrogen, so much helium. And a lot of that has to do with the color it gives out, the spectrum. We'll talk about what a spectrum is, those black lines in front of the rainbow. And we'll get, until people say, no, 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 we don't want to learn all that. We'll move on and get a little deeper, but not today. Okay? Okay. I've lost track of the questions we were going to ask today. Mary Lou, Jordan, I don't know if you did this. I think I asked you for the Alpha and the Beta stars in Orion, Canis Major, and the Big Dipper. Is that right? Did you do that or not?
Yeah,
Is that a yes or a no?
that's a yes.
Okay, let's just deal with the Alpha stars because we're going to run out of time today. What was the Alpha star in Orion?
It was blue, white, Rigel.
Rigel, I think is how you
Yeah,
say it.
Rigel.
Rigel. What about Canis Major, the big dog?
Sirius.
Yes, we all know Sirius. Now, I don't know any of the names of the stars. Well, no, I know two. In the Big Dipper, what's the Alpha star in the Big?
I think there was some interesting stuff about that. Sirius, the Beta star in Canis, didn't used to be the brightest star in the sky.
Okay. And now it's
3 to 4 million years ago.
3 to 4 million years ago. Wait a second. It was the Beta or the Alpha?
The current Beta star, Mirzam,
Okay.
that used to be the brightest star in the sky, or brighter than Sirius.
But not anymore.
It's not anymore now.
All right. Hang on to
And
that
Sirius
thought.
will be the brightest until the next one, I think, which is NR, which is 800,000 to 2.8 million years from now. That star will be brighter.
Okay. All right. Now, who did I ask? Because, okay, two or maybe last time or the time before, we went over the Greek alphabet, the first 5 letters, which astronomers tend to say the Alpha star is the brightest, the Beta is the next, et cetera, et cetera. And magnitude, by the way, is, can I remember? A Beta star is, no, an Alpha star is 1.5, I believe, times brighter than a Beta star. So it's not an even twice as bright or 1/2 or whatever. It's 1.5 times as bright. So you can do the math then backwards if you want and say, okay, if I have good eyes and in the dark sky, I can see maybe magnitude 6. Well, how much brighter is a 1 compared to a 6? And I wrote that down somewhere, but did I bring that piece of paper with me? No, I didn't. So anyway, somebody, I'll bring it next time, I hope to remember.
4 times 1.5 is 6.
What, Bob?
4 times 1.5 is 6.
I don't think it, I think, okay, if you go from 6 to 5, 5 is 1.5 times. The next one is another 1.5 times, which would be
It's a geometric progression.
Yeah. Yeah.
So that's
it's not-
1.5
Yeah.
from 6 to 5 to
Okay.
4 to 3 to, okay, you got 6. So you go to 5, 4, 3, 2, 1. That's 5 times. So it's 1.5 to the 5th power. And we'll use the nice calculator here.
I love calculators, don't you?
That's 11.4 times.
Okay. Yeah, or 12
One.
times, something like that. Yeah. Which is, you could play around with your light bulbs in the house at 20. Well, I'm not sure that's right. 25. What would be 12 times 25 watts? 300? No, never mind. Let's not go there right
Mary
now.
Lou,
What?
I'm not a math person.
She's not a math person. Okay. Sandy, did I on the phone give you an assignment? I cannot remember. Did I ask you about the time that the Milky Way galaxy and the Andromeda galaxy are going to meet because they're on a collision course?
Not that I can remember.
I might not have called you. Okay,
Rima looked that up.
okay. Can you, I don't have my glasses.
Oh, so Rima looked it up and they're moving together. The two galaxies will collide in about 5 billion years.
All righty. Let me just think for a minute. Okay, so maybe some of you didn't know this, but the only thing with our naked eye that we can see that's not in our solar system, at least in the northern hemisphere, and I always forget all the people that live in the southern,
Yeah.
you know, is the Andromeda galaxy, which I believe in a month or so, 6 weeks, when we have another star party, we'll be able to see, which I think is kind of exciting. The only thing you can see with your own eyes that doesn't belong to us, you know, that isn't going around and around in our big spiral galaxy. However, they're moving towards each other at something ridiculous like 300,000 miles per second. Did she write? I
She
didn't.
wrote 70 miles per second.
70 miles
Per
per second. Okay, which is still awfully fast. And therefore, in 5 billion years, the two will, I won't say collide, because that implies a lot of mass to hit each other. And even, you know, really, it's mostly just space, emptiness between all these billions and billions of stars.
They will
So,
intercalate.
pardon?
They
What's
will
that?
intercalate.
What's the word?
Intercalate, intercalation.
Oh, real. That I never heard of that. I was going to say, what was I going to say? That totally blew it out of my mind.
I know.
Pass through. We will
Take your
disturb
hands
each
and
other.
do this. Do this with your hands. I'm intercalating my fingers.
All right, but we'll keep going. We won't.
Well, because.
Yeah, well, some of us will keep going. However, we don't have to worry about that on the Earth because our planet, and once again, we'll have wonderful topics in the future on time. What is time? What was going on before time started? Is there going to be an end of time, et cetera, et cetera. But our solar system is about 15, I'm going to round it off, 15 billion years old. The Earth is, no, back up. What do I want to say here? The Milky Way galaxy is about 15 billion years old. Our solar system is only about 5, is that right? 5 billion? And we have
Billion.
another 5 billion to go before it all ends. So we're not going to be around when the two major galaxies in our neighborhood pass through each other. However, it's fun to think about. All right, we think we have problems nowadays. What else did she write down?
She wrote down
The revolution of our galaxy,
the
right?
revolution of our galaxy 130 miles per second.
Okay, I asked Rima before we got started, how fast are we spinning around in our own galaxy? Think of sitting on a very wide carousel, and there's 6 horses, you know, from the middle of the carousel to the edge, and you're sitting on horse number 4 towards the edge, and so everything's going around and around. How fast is our galaxy going around? Or how fast are, what was that? The galaxy?
Yeah.
130 miles per second. So I wanted to know, I'm sitting on my horse, how long will it take me to go once around the circle so I can wave to my mom, you know, when I come around again? Or another way to say it, how long ago was it that the Earth was exactly, more or less, in the same spot? And what was the answer?
130 miles per second.
No, how many years?
Oh, she didn't write that down.
Okay, well, it's
She couldn't find it.
it's about 240 million years. Wait. I always have to stop and think. No, okay, we can double check this, but I think it was like 2.5 million years. A long time, because that is about when our ancient Homo ancestor, Homo habilis, started making stone tools 2.5 million years ago. So I think that's how long it takes to go around. But it's that or a couple of zeros. We can double check. Well, don't laugh.
I mean, when we're talking about that many zeros, what does a few more matter anyway?
It does matter. Your book, as a matter of fact, Melanie's book that she
Oh, my
bought,
book left out a zero.
I left
Okay,
out a
that's a-
zero, or was it more than one? It was a couple
No.
of zeros.
No, it was 1 0. It said something about
One instead of
10,000.
10.
Yeah.
Right. Well, I happen to know that the Milky Way galaxy is about, let me think, 100,000 light years across. That's even more than 100,000 miles. But in the middle, where the disk is the fattest, it's only 10 light years thick. And your book said 1, and I was reading along, and I said, 1? That's not right. So anyway, all righty. Bob, did I ask you, or did I once again?
Bob had to leave.
Oh, Anne, okay. Did I ask you guys to look up the history of, how do you pronounce it? Thuban in Draco?
Oh, I
Pardon?
don't know.
No.
I don't know.
Okay. Well, I'll go over that. And once again, since I didn't research it, it's a theory I have. We were trying to figure out last time why some stars are now, quote, the alpha star, when they're obviously not the brightest in the constellation. And if this system popped up, I'm going to guess 200 years ago, I don't know exactly when, by modern astronomers, how come a handful of stars are the alpha, but they're not the brightest? And so when we finally figured out where the Cat's Eye Nebula was, because one book I had made a mistake, and then I found it, and it was in Draco. And so when we looked up Draco to get the picture for you guys to see, there in Draco, Thuban, or whatever it's called, was the alpha star, but it wasn't the brightest. And then somebody mentioned, maybe it was Regina, that back 5,000 years ago, I think it was Regina, she likes the history part, Jordan, you have a competitor there, that 5,000 years ago, when the Egyptians were beginning to think about making pyramids, Thuban was the pole star. And that's another topic we have to go into. I mentioned it in passing that in 8,000 years, Vega will be our pole star. Well, 5,000 years ago, it was Thuban, or however you pronounce it, in Draco. And so I'm thinking, oh, maybe back in the day, they weren't considering which was the brightest, but which was the most important. And since obviously a pole star is important, and they used it to line up their pyramids very exactly for the time and their engineering skills, that was why it was called the alpha star. So I thought in the future, maybe we'll do some research on that. We'll find out some anomalies, is that how you say it, of stars that aren't the brightest, but are still alpha, why that is. Okay. What time is it getting to be?
1:50.
1:50.
10 minutes.
10 minutes. All righty. We'll move on to our assignments then for next time and see what we can do here. That was this time. Okay. This will be, I think, for the 14th of September. Let's see. We're going to talk about Jupiter and especially its moons. Jordan, you still there?
Yeah.
Okay. Let me just see here. Do you want a simple one this time?
Sure.
Okay. So this all concerns Jupiter. How far away from the sun is it? What is its diameter? Oh. Shoot. Oh, Jordan, I'm sorry. Scratch that. I got J for Jupiter mixed up with J for Jordan. I have a better one for you, okay?
Yeah.
All righty. You like history? I want you to look up Galileo. That was the early 1600s when he built his telescope. Tell us a little bit, let's not go overboard, just, how big a telescope was it? How does it compare to your binoculars? Or how much bigger was everything that he could see compared to his naked eyes? What date did he look through that telescope and see the 4 moons of Jupiter and said, uh-oh? And what did he mean by uh-oh? Because that discovery of those 4 moons shook up the whole world in the West and wrecked its foundations and built a new house. So,
Okay.
okay? All righty. And if you get interested in it, you might want to find out then, what happened to poor old Galileo because of that. All right?
Yeah.
All right. Regina, you're going to pick this up either by calling me or by listening. Did we press it?
Yeah.
Listening to the recording. Regina, a lot of the information we're going to talk about next time came from what I'm going to call flybys. What are they called? Voyager 1, Voyager 2, et cetera, et cetera, et cetera. Because we're stuck, except for the moon, we're stuck here on Earth, and we have to do everything by robots and our brains. And so, Regina, what were the basic dates of those flybys that made the discoveries that we now know about the outer part of our solar system? And I just bought, I'm going to give it to the library in another week or two, a 4-hour DVD set called Cosmos, which I think was made 15 to 20 years ago, because what they knew then, we know so much more now in 15 years. And I kept saying, I would ad lib their dialogue. Oh yeah, that's true. You didn't know that back then, did you? But we do now because of these various trips to outer space. All righty, Debbie's not here, but I'm going to give her Io, the closest of the 4 moons that Galileo discovered. Sandy, who's still there? Sandy?
Yes.
Okay. You have Europa, Europa, I believe. Europa, the second one out. Mary Lou?
Okay,
Okay. I'm going to give you Ganymede, which, by the way, is larger than Mercury. Ta-da.
how do
A
you
moon.
spell that?
Oh, I don't know. Is it written
Yep.
here? Okay. She'll spell it for you.
GANYMEDE.
Oh, Ganymede.
Yep.
Ganymede. Okay, and Anne, you have Callisto.
Yeah.
Callisto, the 4th one out. Now, you 4, Deb, Sandy, Mary Lou, and Bob and Ann, what I'm basically interested in, if you want to get into how big is each one, diameter, their mass, things like that, what I'm really interested in is the things that are unusual about them. Each of those, there's something that says, I'm the only one like it in the solar system. Or this maybe is where we can find primitive life. Ta-da. One of those moons is a good source for primitive life. Which one is it? Who has it? And why? And where is it? Okay, we could also tell, they all look very different. If you had a science class and you had to do the balls and paint them, make them look like, they'd all be different colors from each other. You might want to talk about how long each one takes to run around Jupiter. Okay, what else have we got here? Jordan and Regina's. I'm going to stick Laura with the original one that I was going to give to Jordan. So that's all the questions I have for next time, and we must be running out of time. There were a few other things. Do we have a minute or two or not? Do we have a minute or two or not?
Yeah, that's one.
Okay, this is just for anybody who wants to do it and double checking possible errors or mix-ups, or why is this have two names? Once again, Corona Borealis. That was the northern crown that we looked at a month ago in the summer sky, the northern crown. Its alpha star has two names. I had called it Gemma, Gemma. But in two probably more reliable books, the name is ALPHECCA. Now, which of those names is correct? And if it's not Gemma, why did the author of my one book call it Gemma? Was it called that once upon a time? So I don't know. Maybe somebody can find out. Any questions before we wrap this up? Sandy, are you going to Florida in 2 weeks?
Yes.
I tell you what.
Exactly, right.
All right. I want you to,
I could give it to you before that.
no. I want you to do something here and there. When it's a clear night, I want you to go out into towards, away from your porch so you can see the southern sky. Or pick some bright star that's either in the southern hemisphere or the northern hemisphere. It's up to you. Okay? Or a constellation. And then
I'll have a view. There are buildings there. I'll probably have a view. I have a view of the sunset
which side is that? South,
on the
north?
west.
I'm sorry, what?
The west.
That's not gonna work.
No.
Well, do the best you can. Maybe you're
Yeah.
gonna have to go out to the park or the beach or something. Choose a bright star either in the northern or the southern sky, like maybe Antares. No, that's gonna be interesting if you choose Antares. Anyway, what I want you to do is while you're up here, at a certain time of the night, it has to be the same time, say 10 o'clock. You go out there, hold your hand out all the way in front of you, put your thumb on the horizon and your index finger where the star is or whatever. Measure the distance between the horizon and where your bright star is. And then do the same thing in Florida. And tell me what the difference is. And the next time Bob and Ann go down to New Zealand, we'll have them do the same thing. Okay, any questions before we shut down? All right, so it'll be in 2 weeks, which I think is the 14th of September. And we will talk about Jupiter and all its amazing moons and poor old Galileo and his big disagreement with the powers that be and what happened to him in the end, etc. And also these amazing moons, these 4 moons that are so amazing, I think. All set? And we'll just leave those on the screen for maybe the 2 weeks. Or can you do that?
Yep.
The images?
Okay.
So if you want to take a closer look at what we had on the screen today, especially the moons, it's kind of fun to see how Io, which is the closest, has the tightest spiral. And then the next one out, Europa has a bigger spiral. And then poor old Callisto's hanging out there sort of a little bit by itself. And then there was another 1 or 2 days in the month when you could see all 4 of them at once. And of course, sometimes you can see the transit as it passes. It's just a black spot going across Jupiter's colorful image. Okay, have fun.
Bye.
Hey, thank you, Mary Lou.
Yep.
Yeah.
Well, thanks,
Yeah.
Melanie, for getting us online.
Yeah.
Bye-bye.
Guys, enjoy Florida, Sandy.
It turns out I don't go to the 18th, so hopefully I'll
Oh,
see
okay.
you then.
Okay, come, Finland.